Hi, Year 10. This video is about reflection of light. So let's look at some pictures of how it looks like in daily life for reflection. So the left one, of course, is just a joke, right? These are not exactly the same as what you see. So let's look at the left one. The left one, you can see this one is what we call the real person. So we call that in general in physics object. And the one inside the mirror, we will call that image. Alright, so let's remember these two names. So for the image itself, we have three kinds of general properties that we must find on the image. So the first one is the size of the image is the same as the object. That means you won't look bigger or smaller in the mirror. The second one is about the image and the object will have the same distance to the mirror. That means if you are 50 cm away from the mirror, the one inside the mirror, which is called the image, all right, and while you are called the object, will also be 50 cm away from the mirror. So that's the second property. The last one is saying the image is laterally inverted. Usually you say inverted, it means upside down, like A inverted will be like that. But laterally inverted, it means it is horizontally flipped. That means for B here, what you see in the mirror will be something like this instead. If you are interested in seeing why is horizontally flipped, you can try to check out this video from the YouTube channel Physics Girl, and she will tell you a bit more about that. So looking at this simulation, you'll find out you can drag the object around into the mirror, and then you see the image, and you try to see the diagram of the reflection, and then this is the eyes, and obviously the solid B will be object and the opposite one will be the image. Alright, and that is how we call in general. And in the middle part here, if we try to draw with a yellow color of pen, we can see and try to draw out the normal line. Alright, normal line is defined as 90 degrees with the surface. In maths, you learn about quadratic equation and you draw parabola, and you should have learned how to define the tangent of certain point on the quadratic equations, right? So the yellow one is the tangent, and you can always try to draw one more line which is at the same point but perpendicular to the tangent, so that the green line is always at 90 degrees to that point of the parabola. So that's the definition of normal line, which is an imaginary line actually. So in physics, if you got, let's say, this three-plane mirror, what you'll be doing is you can try to draw three different normal lines like this, and whenever the light is coming shooting on that point of the plane mirror, the light will be reflected, all right, with the same angle, incoming and outgoing, all right, and we call that incident and reflected angle. In other case, there's something actually called the concave mirror, and if the light is shooted to this point, what happens is the normal line will look like that, and same as other point, but this time the normal line will be a bit different, all right, and that is called the convex mirror here. All right, but don't worry, you won't be asked about convex mirror, all right, in IGCSE, but just the plane mirror like these three cases. And by the way, there is one more thing called the opposite of the convex, which is concave, right? Concave mirror. So you can also imagine how the normal line look like, which is varying along the whole mirror. So some of them will be like this, and some of them will be like this. So let's look at some daily life example. Let's say this picture is very classic. So say this is the eyes. This is how we usually draw in physics, and the light will go straight from the image towards your eyes actually, but the real light was actually from the object itself, all right, reflected on the surface of course, you can see the normal there and object and image here. But it's really hard to draw it in 3D. So let's change it to 2D instead. So here is a setting. All right, I try to convert this into 2D so that we can draw it on paper. So let's say this is object. All right, I really want you to try and see if you can try to draw the image here like this. All right. Be careful that when you try to draw the image, it has to be the same size, same distance from the mirror, and it should be laterally inverted. All right, so that, let's say, if you try to map the ear's position from object to image, it should be the same, and same for the any part of the object. All right, of course, I'm not drawing perfectly here. So let's say if we start to draw the lights, we must try to fix one point first, because you can't draw the whole thing, like all the lights at once. So let's just focus on one point. Remember that lights would only go straight, all right, from our perspective. So when you try to draw, I always try to draw from the image, go straight to the eyes. But of course, inside the mirror, those lights are virtual, so you draw it in dotted line, and then you try to connect the line from the object and go into your eyes, right, from the surface of the mirror. And then you can try to draw the normal, indicate I and R, which are the incident angle and reflected angle. And remember, I and R will always equal, because this is the law of reflection that we find. All right, so later on we will perform some experiment in the class and see if this is true. But let's remember this first, right? The law of reflection with I and R equal, but not in refraction. Remember, that will be different.